Hello class, today we have a lesson over derivatives of exponential functions. So we're going to look at a couple of instances, and they're very simple looking. So there's one property that says if you take the derivative of e to the x, it equals e to the x. Now that's a little too simple sounding, so let's kind of break this down. If we're taking the derivative of e to some variable, the answer is e to that variable times the derivative of that variable. Sounds kind of interesting, so let's go ahead and take a look. Alright, so I have the derivative of e to the 2x plus 1. What does this equal? Well, according to my rule, it's going to be e to the 2x plus 1 times, well, what's the derivative of 2x plus 1? That's just 2. Okay? Again, e to the u right here, du right here. Simplified down, we could just say this is 2e to the 2x plus 1. Not that bad. Let's try some other ones. What if I give you x times e to the x? Whoa. There's a distinct multiplication operation going on right there. How do we take a derivative of two things that are multiplying? We have to use the product rule. So in taking a product rule, we want to take the derivative of the first operation. Well, the derivative of x is 1 times the second operation, which is just e to the x, plus the first operation, which in this case was x, times the derivative of the second operation. And as we said at the beginning, the derivative of e to the x is still just e to the x. In simplifying all of this, I realize I have e to the x plus x e to the x. I could simply factor out on e to the x if I felt the need, but you guys kind of get the idea from there, don't you? Alright, let's look at a slightly more challenging one. I have the derivative of e to the x divided by 2x. Now, there's a distinct derivative operation going on here, which means we have to use the quotient rule. And remembering how to do the quotient rule can be challenging, but I just remember if I'm going to the club, the first thing I do is I get low. That's right, we're going to go low d high, so low. D high is the derivative of the top, which is the derivative of e to the x, which is just e to the x, minus high, d low, and the derivative of my low portion is just 2, all over low, or low squared, so we say 2x, the entire quantity, squared. Of course, we can always safe stop it right there, be able to break that down if we need to, but ultimately that's just our answer. So very good. That's a good review over derivatives using exponentials. Now let's go talk about integrals. Alright, so the integral of e to the x dx is e to the x plus c. That makes sense because the derivative of e to the x is e to the x dx. Funny how that works. So let's look at a couple of examples. If I have the integral of e to the 3x minus 1, well, that's interesting looking. Why don't we take this 3x minus 1 and call it u? Therefore, I now have a du, which is just 3. Okay? Well, do I have a 3 anywhere in this equation? No, not really. So I'm going to have to introduce one. So what if I said the integral of 3 e to the 3x minus 1 dx? Well, that's fantastic, but I can't just write a 3 there unless I balance everybody by putting a 1/3 out front. Well, now that 1/3 and that 3 would cancel each other out, so it's like I didn't even put a 3. So let's try to look at this. Now I have a du and a u, so really I have 1/3 times the integral of e to the u du. And that's really convenient. Oh no, what have I done? Okay, hold on. Everyone relax. No one panic. Okay. That's salvageable. There's a thing I can do. Oh, yep, making it small. Making it tiny. Put it up there. Okay, hold on. Oh no. Alright, so the integral of e to the u du is just e to the u. The 1/3 will follow through. And don't forget your c. Now, of course, we can clean this up. I don't like the u. It's kind of ugly. So I can put 1/3 e to the 3x minus 1 plus c. And that's my answer. Pretty convenient, don't you think? Let's go ahead and try another one. So what if I give you a problem like this? It says the integral of 5x times e to the negative x squared dx. Well, the first thing I don't like, or the first thing I notice, is I have a 5, and now that's a constant 5, so I can always factor that out. So I'm going to go ahead and factor that out. So now that I factored out the 5, one thing I notice is I can really, if I wanted to, call this exponent u, and I can take the derivative. So let's go ahead and find my u and my du. I'm going to do that now. So we see that my u is equal to negative x squared, and my du is equal to a negative 2x. Well, there's some good things and some bad things. The first good thing I notice is, wait a minute, this negative 2x helps kind of sort of take care of that x that I just have hanging around. All we have to do is put a negative 2 in front of it, like such. Now, if I were to just write this negative 2 just like that's fun looking, but I can't just write a random number. That's against the rules. So how can I balance it? Well, if I'm going to multiply a number in, I can balance that by dividing a number out. Okay? So let's look at this now. Here's my u, and here's my du. So really, I have negative 5/2 times the integral of e to the u du. And that's a really easy integral. Let's show it. So the integral of e to the u is just e to the u. So we have negative 5/2 e to the, well, my u was a negative x squared. And don't forget your plus c. And there's my answer. Just like that. Awesome, guys. Well, I hope you all learned a lot. I hope you guys were very respectful and took notes. I hope you guys are being on your best behavior. I'm stuck in Austin, Texas. It's a terrifyingly terrible place. I mean, it's a wonderful university full of bright minds. And I'm going to enjoy it the best I can. I secretly have Texas A&M socks on, though, so that makes me kind of happy. Anyway, peace out, guys. Do well. Catch y'all tomorrow.